Hello, everyone. In this video, we're going to see some variations in the fatty acid breakdown. In the previous video, we saw how standard, fully saturated, even numbered fatty acids are broken down. So let's look at some variations. First of all, there are variations in length. Anything longer than 20, let's say 22 carbons, mitochondria cannot handle it. So first, there's very long fatty acids. They undergo beta oxidation in peroxisomes. It's very similar, different enzymes, but the same chemistry, okay? And they are very specific for the long fatty acids. There is no ATP synthase there, so the electrons are transferred eventually to oxygen in peroxisome, so that you generate hydrogen peroxide. Also, peroxisomes use a specialized, a dedicated carnitine shuttle that's different from the one that's used in mitochondria, but the same principle, same mechanisms, other than the terminal reaction that there is no ATP synthase there, so there is no membrane system like we have in mitochondria, so you won't get any ATP out of these extra carbons that are flipped. But once they get shorter, then these fatty acids can engage with the mitochondria system. So what about odd carbon fatty acids? So you end up with propionyl, not acetyl-CoA. So you end up with 3 carbons instead of 2. So that's fine, not a problem. That will give you succinyl-CoA in the end. And as we said, usually if you break out most of your fat, it's going to be acetyl-CoA. But so we're talking about the last 3 carbons now. Okay, you even if you have an odd numbered fatty acid, you proceed 2 at a time, 2 at a time, 2 at a time, until you reach the last 3, and that will give you succinyl-CoA, which you can use for gluconeogenesis, and of course, it's part of the TCA cycle. So some of the variations come about now from branched fatty acids. So they're not very common, but they do exist, especially in plants. So you have these methylations, methyl groups, along the fatty acid chain. And the bottom line is you get the pieces. I mean, you keep breaking down as you keep going, for a normal unbranched fatty acid. So you break them down 2 at a time, but if you have stumps, so to speak, along the way, so be it. They come off, okay, and they become unusual end products. In this case, isobutyryl-CoA. When you have this little branch, if it's of course just one in the middle, and then you have propionyl-CoA, so that gets converted again to succinyl-CoA, so you can use it for other things. And whatever is just as a simple 2 unit, it gets converted to acetyl-CoA. So branches are not necessarily a problem. The same enzymes work just fine. What about unsaturated fatty acids? So here we have one little problem, which is not actually a big one even. So unsaturated fatty acids means you have double bonds. Now the double bond is part, like that's the first reaction we do in the 4-step beta oxidation, is to generate a double bond, which then gets hydrated. You get a hydroxycarbon, which can then oxidize the ketocarbon, and so on and so forth. So here you come with a pre-made double bond. So that's good if the double bond is in the right place. If not, then you have to move it between the beta and gamma carbons, so you can proceed. So the only issue we have really is to move the double bond at the right place, and the N-oyl-CoA isomerase will do that. Okay, so there is your initial double bond, okay, and then it gets moved over to the next position. So very, very simple, very straightforward reaction. What happens then is to feed them to step 2, 3, and 4 of the beta oxidation, which means you bypass the first one, which generates a double bond. You don't need to do this here because you already have a double bond. So you lose the 1-FADH that you generated in the first reaction. So you're going to get a little less ATP from that fatty acid. Does that make sense? Of course. It's not. It's a little more oxidized than the fully saturated fatty acid, so you're going to get a little bit of less energy out of it in the end. There it is. So that's the very first step that generates the FADH. For that double bond, when you break down the unsaturated fatty acid, that's what you're going to lose. we're going to close with this video, and then we have ketogenesis.